So elimination can be a great method. And we're going to show you some more examples. This first one, you notice it has a lot of fractions in it, right? Well, the great thing is you can clear those fractions because we've worked on that before. So you look at that top equation and you think about, well, what's the LCD of 3 and 2? 6, right? So we're going to go ahead and multiply through by 6, and then that's going to get rid of those fractions for me. So I'm going to get, yeah, I'll write it like this. 6 times 1/3 x minus 6 times, I should put like something like that. Okay, 6 times 1/2 y, and there was a minus sign between them. So, and then you get 6 times 1. Now, when we simplify that, we're going to get, 3 goes into 6, 2, so you're going to get 2x, 2 goes into 6, 3, so minus 3y equals 6. Now that's a much friendlier equation, right? Okay, so the bottom equation, we're going to do the same thing. We're going to, well, not exactly the same thing, but we're going to clear the fractions. So we're thinking about 4 and 2. What's the smallest number? We're looking at those denominators. What's the smallest number that both 4 and 2 will go into? 4. So I'm going to multiply by 4. So I get 4 times 3/4 x minus 4 times y, and then 4 times 5/2. And so I get, those 4's are canceling, I get 3x minus 4y equals, and then 2 goes into 4 2 times, and I get a 10. So if I take the green equation, I'm going to go way over here to the left, and I recopy that green equation. 2, oops, I put it in green, erase that. Try again. 2x minus 3y equals 6. And then if I copy the blue equation that I have without the fractions, 3x minus 4y equals 10. Now I can start the problem. So that was just to get rid of the fractions. And now I have the same two equations, or equivalent equations, but they don't have any fractions in them. And so now I can think about eliminating either the x's or the y's. This time I don't have one positive and one negative, so it really doesn't matter which variable I get rid of. I think I'll go ahead and get rid of the x's this time because we haven't done that before. So I'm going to go ahead and multiply by, I feel like I need a new color. I'll multiply the top one by, let's see, a 3. Because I'm going to try to get rid of the x's, right? So I have to think of, in this column here, what number do both 2 and 3 go into? 6, right? So I'm trying to get them to be a 6x. And the bottom one, I'm going to need that to be a negative 6x. So I'm going to multiply by a negative 2. So right here, I'm going to get a negative 6x. And then up here, I'm going to get a positive 6x, right? Okay, so I'm just showing you what's coming. Okay, so the top equation, you still have to do all that distributing. Yeah. Okay, and I get 6x minus 9y equals 18. And then on the bottom, give it red, I get, and then I have to distribute here, and it's a negative 2, right? So when they're both the same sign, you have to make sure you multiply through by one positive and one negative, so you can get a positive and a negative to eliminate. Negative 6x plus 8y, right? Because negative 2 times negative 4y is going to be a positive 8y, and then that's going to equal a negative 20, I think. Yeah. Okay, great. So let's go ahead and add these together and see what we get. 6x minus 6x, those are out. That's the eliminating part. And now I get a negative y, negative 1y if you want to put a 1 there. And then 18 and negative 20 is negative 2. Okay, I'll divide both sides by negative 1. And so I get y equals 2. Okay. Now I have to pick an equation to go to. I've got a bunch of equations and all kinds of different colors. I have to pick an equation to plug that y into. So I think I'll take that green equation, 2x minus 3y equals 6. looks like a friendly equation, so this one. And I'm going to put in the 2 for y. So 2x minus 3 times 2 for the y. And then I'll have to solve this. 2x minus 6 equals 6. Add 6 to both sides. And so I get 2x equals 12. Add both sides by 2. And so I get x equals 6. Okay, so it all seemed to work out pretty nice. I'm getting a solution, an ordered pair of 6, 2. Now, I could plug those in, kind of do it in my head maybe. If I put the top equations, 1/3 of 6 is 2, minus 1 is 1. Yeah, that one seems to work. And then I'd have, what, 18/4, the other one's harder to do, minus 2, which would be 8/4. So I'd have 18 minus 8, which is 10/4. Yeah, that reduces to 5/2. Now, it's much easier to check these by writing them out, but it's a little bit of work to check them with the fractions, and I'm kind of out of room. So, but it looks like they work. It says solve the system by elimination. Well, it's not really set up for elimination. Okay, so, but it says to do that. So we will do that to show you. Like if you're like, man, I always want to do elimination, we'll show you how to do that. So first of all, I don't like the looks of that fraction in the bottom equation. That's one of the problems. So I'm going to multiply through by 3 just to get rid of that fraction. So I'm going to get 3y equals negative 15 plus 5x. Okay? I haven't really done a whole lot. I just wanted to get rid of the fraction. And I did that by multiplying that equation. It had the one fraction in it, and so I multiplied through by its denominator, 3. 3y minus 15 plus 5x. Okay. The other problem is it's not set up in that convenient, I got the x term and the y term equals the constant. And so I would like it to be set up like that. So I'm going to move this over to the other side and get negative 5x plus 3y equals negative 15. Now I want to use that equation with the top equation. So where can I write all these? So let's make this green. I should have done the other one in green. That top equation, I'm just going to copy it down here. I think something exciting is going to happen. Okay, so the bottom equation, I got it all in, the x term plus the y term equals constant. So I got it in that form. It had been in slope, well, kind of in slope and slope form. But I got it so in the form for elimination. The top equation, I've just recopied that in green underneath. Now, it looks like if I add these equations, the x's are going to eliminate. Great. Now, some of you might be looking ahead, but those x's are out because negative 5x and 5x is 0. And the 3y and the negative 3y, those are out. Well, that hasn't happened before, has it? Okay, so what do we have on the left-hand side? We have 0. Now, what happens on the right-hand side? Well, negative 15 and 15 is also 0. So this is one of those cases where we're not going to get one solution. We've lost our x and our y. We have no variables. We just have 0 equals 0. Well, the good news is, I guess, it's true. 0 does equal to 0. And so it turns out that this is one of those cases where those lines were actually the same line. They were coincident lines, and so there's an infinite number of solutions. So we're just going to write infinite number of solutions. Don't try to squeeze an x in or just think the answer is 0 or whatever. We've lost our variables, and that's okay. It just means it's not the consistent system where you get one solution, okay? And so there's actually an infinite number of solutions here.